This question is asking us to find the expected value of a game or an activity. In this case, you have a game pulling out a bill, a monetary bill, so some money out of a bag. It's got a certain number of bills, so you have 50 $1 bills. Okay, so let's find out how many total bills we have. 50 $1 bills, we have 10 $5 bills, 4 $10 bills, and 3 $20 bills. So there are a total of 67 bills in this bag, and you just get to pull one out. So let's find out what the expected value is. As it says in our notes down here, expected value, you take the amount you win, could be dollars, could be points or tickets or something, but a lot of times it's dollars. So the amount you win, multiply by the chance of winning that, and then you add the next one, and you add the next one, and you add the next one. When you add all those up, that outcome is your expected value. What that means is how much do you expect to win on average, right? So on average, how much will you get? So on average, per game, what will you have? So in this particular example, what I like to do is I like to set up a table, as you can see. So I have the win, so you could win $1, you could win $5, you could win $10, and you could win $20. There's no blank papers or anything in this case, so there's no like $0 bills or anything. If there were any possibilities of not winning at all, even though like that's an outcome, not winning any money, then you don't include that in your table because it doesn't count toward your value because you'd just be multiplying by 0. So in this case, the percent chance of that occurring, would be going to be 50 out of 67. That's the percent chance you get a 1. Let's see, there are 10 $5 bills, so that's 10 out of 67. $10 bills, there's 4 of them, so 4 out of 67. And then you have 3 of those, of the $20 bills. And then you just multiply. So that would be then 50 out of 67 when you just multiply by 1. But this would be another 50 out of 67 if you multiply by 5. You're just multiplying the numerator. So this is 40 out of 67 when you multiply the numerator, and then 60 out of 67 when you multiply those. And then you're going to add all those up, and that is going to be your expected value. So you can just use your calculator, 50 divided by 67, plus another 50 divided by 67, plus 40, and plus 60. That comes out to be a total of $2.99. So that is our expected value, right? That expected value is $2.99 to the nearest penny. What that means is that if you were to play this game 100 times, you would expect to win on average $2.99 per time you play it, right? So there's no outcome where you're actually going to get $2.99, but that's what I mean by on average. If you were to play this game a bunch, add up all the winnings, divide by how many times you play, that's how much you'll win on average. So then the next question is this a fair game, right? A fair game is where you pay exactly what the game is worth. And what you see up here is that you are charged $2.99 to play. Well, look at that. Those two things are the same, right? $2.99 to play. Our expected value is $2.99. So yes, that is a fair game, right? A fair game is when both sides are even, when you pay exactly what the game is worth. It's not fair if you always win, just like it's not fair if you always lose, or you could lose, right? I mean, so in this case, fair game is when things are exactly the same. So unexpected value, add up all your products of the win times their chance. That is the expected value.